Hello. So today we will start our second chapter, that is complex numbers. First, I will give you a few important points on this chapter, synopsis, and then we will go to the problems. What is a complex number? We are going to learn that first. How does a complex number looks like? A complex number is generally in the form x plus iy. So it has two parts. The part x is called real part, and the part iy or simply y is called imaginary part. So every complex number is named by z equal to x plus iy. So if you want to say real part of z, that is x. If you want to find imaginary part of z, that is y. Now the main thing you have to notice is the I which is present here. I is called an imaginary number. And this i's value or I is taken as square root of -1. That means when you square both the sides, I square is taken as -1. Every complex number that is z equal to x plus iy can also be written in the form of ordered pairs x coordinate, y coordinate. If you have 0, 0 can be written as 0 plus 0i. If you have a real number that is x, you can write it as x plus 0i. If you have an imaginary number, that means you can write it as 0 plus iy, which you can write it as iy. Now coming to the powers of I, if you have I power 0, that is 1. I already told you I square is -1. But all other powers, if you take I power as 4n, that will be equal to 1. That means if the power you are expressing as multiple of 4, I power 4n plus 1, multiple of 4 plus 1 extra, that can be written as I. Then I power is multiple of 4 plus 2 extra, that will be written as -1. I power 4n, multiple of 4 plus 3 extra. So that is written as -I. You can memorize these so that it will be useful for you. Then whenever you have square root of -a into square root of -b, you have to write it as minus square root of ab if a is greater than 0, b is greater than 0. And both a and b belong to set of real numbers. But the same thing, square root of a minus square root of b, can be written in another way also. Square root of a into square root of b can be written as square root of ab also. But this will happen when a and b both are equal to 0. Now two complex numbers z1, that is x1 plus I y1, and z2, that is x2 plus I y2, you can say that z1 is equal to z2 if the real parts x1 and x2 are equal and the imaginary parts y1 and y2 are equal. For example, I will give you one complex number z1 as x plus 4i, and I'll give you another complex number z2 as minus 4 minus 2iy. I will say z1 and z2 are equal. Now you have to find what is x, what is y. So because z1 and z2 are equal, I can equate the real parts x equal to minus 4, and I can equate the imaginary parts, that is 4 equal to minus 2y or y equal to minus 2. In this way, I found what is x, what is y, which is asked in the question. Similarly, another example I will give you, that is, I have x comma y, a complex number in this form, which is equal to again x comma y in the ordered pair form. Then I can make the x coordinates equal and then y coordinates equal. I can solve these equations simultaneously. How to solve? I will multiply the second one, the second equation, by minus 4. So first equation is a plus 4b equal to minus 6. Second equation becomes 12a minus 4b equal to minus 20. Now I will add these two equations so that I will have 13a, these two cancel, equal to minus 26, or a equal to minus 2. Once I get a equal to minus 2, I'll put it in this equation. Minus 2 plus 4b equal to minus 6. 4b equal to minus 4. B equal to minus 1. So in this way, I got a equal to minus 2 and b equal to minus 1. Then if you are given two complex numbers a plus ib and c plus id, we cannot compare them. We can't say they are equal. We can't say one is greater than the other, or we can't say one is less than the other. Two complex numbers can never be compared. The next synopsis is, if you have four consecutive powers of I, that means I power n, I power n plus 1, I power n plus 2, I power n plus 3. These all are four consecutive powers of I. Consecutive means coming one after the other. First n, immediately after n, n plus 1, immediately after n plus 1, n plus 2, immediately after n plus 2, n plus 3. Such powers of I, which when you add, you will get 0. The next synopsis, which is very important, addition of complex numbers. Z1 a complex number, a plus ib form. Z2 a complex number, c plus id form. If you want to add Z1 and Z2, you have to add the real parts a plus c. Then take I common and add the imaginary parts b plus t. Similarly, if you want to subtract two complex numbers, z1 that is a plus ib and z2 that is c plus id, you are doing z1 minus z2. So from the real part a, subtract the real part c. Take I common, from the real part b, subtract the real part d. Actually, B and D will be imaginary numbers only, but they can be called as imaginary parts. B is a real number, of course. D is also a real number. You're subtracting the two real numbers, but they belong to the imaginary part. Similarly, if you want to multiply two complex numbers, that is Z1 equal to A plus IB and Z2 equal to C plus ID, then there is a shortcut form for multiplication for Z1 into Z2. That is AC minus BD. The real part will be AC minus BD. Plus I into the imaginary part will be AD, AD plus BC. So AC minus BD is the real part. AD plus BC is the imaginary part. Similarly, dividing. If you have Z1 as A plus IB and Z2 as C plus ID, you are dividing Z1 by Z2. Then the shortcut form is, in the real part you have AC plus BD. And denominator C square plus D square. This C square, this D square. Whereas I common, in the imaginary part you will have BC. First you have to write BC, then you have to write minus AD. So BC minus AD, denominator will be same. That is C square plus D square. The next synopsis is, if the next point of the synopsis, if Z is X plus IY, then Z bar is nothing but conjugate of Z. So Z bar will be X minus IY. When you add Z and its conjugate, so you will have X plus X to X, whereas IY minus IY will cancel. And so this is called purely real number. When you take Z into Z bar, you will get X square plus Y square. This is also a purely real number. If you have Z, a complex number, as X plus IY, then modulus of Z is written as modulus of Z, and it is defined as square root of X square plus Y square. Whereas amplitude or augment of Z, that is theta, is given as tan inverse Y by X. Now, amplitude or augment means theta. This theta can take many values, but the principal value of theta should be in such a way that theta must be taken between minus pi and pi always. So, if theta is taken in first quadrant, then it will be theta only. In first quadrant, it will be measured as theta. But if you want to measure theta in the second quadrant, you have to take the angle as pi minus theta. If you want to measure theta in the third quadrant, then you have to take the argument as minus pi plus theta. And if theta has to be measured in the fourth quadrant, then it has to be taken as minus theta. There are many properties of conjugate and moduli. So we will study about the properties. I will number. The first one is modulus of z will be greater than or equal to 0. But modulus of z will be equal to 0 if z is 0. The second property is z bar whole bar will be equal to z only. The next property is modulus of z and modulus of z bar both will be equal. Modulus of z square is same as z into z bar. Then z1 plus z2's conjugate or bar, whole bar, will be z1 bar plus z2 bar. Similarly, z1 by z2 whole bar will be equal to z1 bar by z2 bar. And z1 into z2 whole bar will be equal to z1 bar into z2 bar. Modulus of z1 plus z2 will be less than or equal to modulus of z1 plus modulus of z2. Modulus of z1 minus z2 will be less than or equal to modulus of z1 plus modulus of z2. Then the 10th point is real part of z can be written always as z plus z bar by 2 and imaginary part of z can be written as z minus z bar by 2i. Then the next property is z1 plus z2 modulus whole square plus z1 minus z2 modulus whole square will be 2 into modulus of z1 square plus 2 into modulus of z2 square. In this way, these properties, which are of course not interesting, but you can learn. While doing the problems, you will understand more. Next, we will learn about De-Moivre's theorem. Every complex number z, which is in the form of x plus iy, can be written in the form r into cos theta plus I sin theta. This form of writing complex number is mod amp form. So, how will you know what is r? R is nothing but modulus of z, that is square root of x square plus y square. And theta is nothing but augment of z, that is tan inverse y by x. But in order to get theta, you have to take a system of equations, that is cos theta equal to x by r and tan theta equal to y by x, sine theta equal to y by r. Three equations are there. In order to get tan theta equal to y by x, or in order to get theta that is tan inverse y by x, you have to use these two as simultaneous equations. Then only your answer will be correct. Now, this cos theta plus I sin theta is actually the definition of e power I theta. And cos theta minus I sin theta is actually the definition of e power minus I theta. So all these I was explaining you to know about the basic thing that is modern form. But what is De-Moivre's theorem? If you have cos theta plus I sin theta whole power any number n, then we can use something called De-Moivre's theorem. And according to that, you will get many values for this. But one of the values easily you can find. How? You can just bring this power n inside and multiply to theta. So the answer for this will be cos n theta plus I sin n theta. But remember, it is one of the values of cos theta plus I sin theta whole power n. Many values will be there. The next is cube root of unity. When you find cube root of 1, cube root of unity, you will get three answers. First is 1. The second is minus 1 plus I root 3 by 2. The third one is minus 1 minus I root 3 by 2. This you will write it as 1. This in short you can write as omega. And this in short you can write it as omega square. So for cube root of unity, you have three answers. 1, omega and omega square. If you take omega as minus 1 plus I root 3 by 2, if this is omega, then omega square will be minus 1 minus I root 3 by 2. But if you take omega square as minus 1 plus I root 3 by 2, then omega will be minus 1 minus I root 3 by 2. Anything you can exchange and take also. Then all the cube roots of unity, if you add, the result will be 0. And all the cube roots of unity, if you multiply omega cube, that will be equal to 1. So as we are finding cube root of unity, we can find nth root of unity also. For nth root of unity also we have formulas. That while doing the problems, we will discuss. Now, next thing is finding nth root of unity. To find the nth root of unity, first of all, we must have cos of 2 pi r by n plus I sine of 2 pi r by n, which we will write as some number or denotion as alpha r. In short, I can write it as e power 2 pi r by n I. Now, if I give r's value as 0, 1, 2, 3 up to n minus 1, in this formula, I will get n roots of unity. So alpha 1, first root of unity. Alpha 2, second nth root of unity. Third nth root of unity. Fourth nth root of, like that I will get nth roots of unity. If you want first fourth roots of unity, I was telling you this formula for nth roots of unity, isn't it? That means for unity, if you take nth root of unity, this is the answer. Not only cube root, fourth root, fifth root, sixth root, seventh root, eighth root, like that. Suppose if you take square root of unity, you will take only 2. If you take cube root of unity, you will take 3. I'll show you how. First, I will start with r equal to 0. When I put r equal to 0, I have alpha 0. So only one root. If I take r equal to 1, I will get alpha equal to alpha 0 and alpha 1. Both I will get. If I take r equal to 2, then I will get alpha 0, alpha 1, alpha 2. So here these are square roots of unity. These are cube roots of unity. Like that, fourth root of unity, I have to take r equal to 3. Then alpha 0, alpha 1, alpha 2, I will have 3 cube roots of unity. And alpha 3, fourth root of unity. Like that, I can get nth roots of unity using this formula. Now suppose I will give you one example. Already cube root of unity I gave you. You need not worry about this formula. When we do the problems, when we come across this problem, I will tell you. So first of all, I will take fourth root of unity now. Fourth root of unity means I need 4 answers. So one answer will be 1, the other one will be minus 1, the third one will be I, and the fourth one will be minus I. Now, how did I get this? How did I get 1 minus 1 and all these? In this formula alpha r, first I will put r as 0. So what I will get? Alpha 0, that is cos 0 plus I sin 0. Cos 0 is 1, I sin 0 is 0, so answer is 1. I got the first root. I'll put r as 1. So alpha 1. So what I will have? Cos, because r is 1, 2 pi by 4. Remember, I am finding fourth root of unity. So n is 4. Nth root of unity, fourth root of unity. Cos 2 pi by 4 plus I sin 2 pi by 4. So cos pi over 2 is 0. Sin pi over 2 is 1. So I have I as the answer. I got this root of unity. Fourth root of unity, this one I got. Next, I will put r equal to 2. Alpha 2 will be cos 4 pi by 4 plus I sin 4 pi by 4 in the formula. So cos pi is minus 1, sin pi is 0. So I got another root, that is minus 1. I'll put r equal to 3. Alpha 3 cos 6 pi by 4 plus I sin 6 pi by 4. So cos 3 pi by 2 is 0. Sin 3 pi by 2 is minus 1. So I got minus I. In that way, I got 4 roots. I can stop. So if I take r equal to 0, 1, 2, 3, I got all the fourth roots of unity. Like that, you can use this formula to find nth roots of unity also. Now, geometrical interpretation of multiplication of complex numbers by I, we will discuss. What is this? For example, I will give you Z1 as R1 into cos theta 1 plus I sin theta 1. In short, I can write R1 cis theta 1. If I give you Z2 as R2 cos theta 2 plus I sin theta 2. In short, I can write R2 cis theta 2. If I want to multiply Z1 and Z2, I will multiply R1 and R2, but when I take cis and the angles, I will add up the angles. That means the full form is R1 R2 into cos of theta 1 plus theta 2 plus I sine of theta 1 plus theta 2. Similarly, if I want to divide Z1 by Z2, I will divide R1 by R2, but when I take cis, I will subtract the angles theta 1 and theta 2, theta 1 minus theta 2. So the long form is R1 by R2 and coming to cis into cos of theta 1 minus theta 2 plus I sine of theta 1 minus theta 2. This is what I have. Then, if I want to write minus Z1, then I have to write R1 into cos theta 1 minus I sine theta 1. These are the different forms. Similarly, there is one more form also. If I want to write I, only I can write it as cos pi by 2 plus I sine pi by 2. This is the form of writing I. And if I want to write Iz, I can write it as R into cos of pi by 2 plus theta plus I sine of pi by 2 plus theta. These are some important formulas. If you learn, that is good for you. Shortcut formulas. So as you have learnt in coordinate geometry, with complex numbers also you have some formulas. That is section formula. Suppose there is a line, a straight line. The end point is A, denoted by complex number Z1. The other end point is B, denoted by another complex number Z2. Suppose there is a point C which divides the line in the ratio m is to n. The ratio is m is to n. Then C can be written as a complex number Z, and that is mz2 plus nz1 by m plus n. In geometry, we have some more formulas. Suppose if there is a parallelogram, the first vertex is A, represented by Z1. Second vertex is B by Z2. Third vertex C, complex number Z3. Fourth vertex D, complex number Z4. Then in parallelogram, we know that diagonals bisect each other. AC diagonal bisect BD diagonal and BD diagonal bisect AC diagonal. Diagonals bisect each other. So I can write Z1 plus Z3 by 2 will be equal to Z2 plus Z4. I'm writing Z4. Z2 plus Z4 by 2. Or I can write Z1 plus Z3 equal to Z2 plus Z4. Coming to rhombus. Again, rhombus is a figure like this. In rhombus, the vertex A as Z1, B as Z2, C as Z3, and D as Z4. If you see in diagonal also, you can take here AC and BD in case of diagonals. So in rhombus also the diagonals bisect each other. So one point is diagonals bisect each other. And the next point is the adjacent sides are equal. Adjacent sides are equal in rhombus. So you can say Z1 plus Z3 will be equal to Z2 plus Z4 and modulus of Z4 minus Z1 will be equal to modulus of Z2 minus Z1. So two things you can say about rhombus. Coming to square. In square also, the vertices A is denoted by Z1, B by Z2, C by Z3, and D by Z4. In square also, diagonals bisect each other. And then all sides are equal. Adjacent sides are equal, but all sides are equal in square. So for adjacent sides equal, that was in rhombus, but here all sides equal. Diagonals bisect means you can write Z1 plus Z3 will be equal to Z2 plus Z4. When all sides are equal, you can write modulus of Z4 minus Z1 equal to modulus of Z2 minus Z1 equal to modulus of Z3 minus Z1 equal to modulus of Z4 minus Z2. Similarly, we will see the case of rectangle. In rectangle, A is given by Z1, B as Z2, C as Z3, and D as Z4. In rectangle, I will say diagonals bisect each other. And then I can say the diagonals will be equal also. Not only bisecting, the diagonals will be equal. So for diagonals bisecting, I can say Z1 plus Z3 will be equal to Z2 plus Z4. Whereas diagonals equal means Z3 minus Z4 equal to Z4 minus Z2. For this, we can see that. The next important thing is centroid, incentre, orthocentre, and circumcentre of the triangle. Suppose you have a triangle ABC. And the sides of this triangle are A, B, C. Of course, angle A, angle B, and angle C are there. First thing is centroid. The centroid G of the triangle we will find. A is Z1, B is Z2, and C is Z3. So if you want to find centroid, as you know, you have already learned in coordinate geometry formula for centroid. In the same way, here also we have formula for centroid in complex numbers. That is 1/3, 1 by 3 into Z1 plus Z2 plus Z3. Similarly, this is denoted by G, I said. So in center also there is a formula denoted by I, and that is AZ1 plus BZ2 plus CZ3 by A plus B plus C. For circumcenter, that is S, the formula can be represented in the form of determinant. That will be easy. Modulus of Z1 square, modulus of Z2 square, modulus of Z3 square, and then Z1, Z2, Z3, 1, 1, 1. This forms the determinant in the numerator. And in the denominator, the determinant will be Z1 bar, Z2 bar, Z3 bar, Z1, Z2, Z3, and 1, 1, 1. This is how circumcenter's formula can be remembered. The next is orthocenter. One more is left off. For orthocenter also, if you remember as determinants, it will be easy. In the numerator, you will have Z1 square, Z2 square, Z3 square, then Z1 bar, Z2 bar, Z3 bar, 1, 1, 1, making a determinant. To that you have to add mod of Z1 square, mod of Z2 square, mod of Z3 square, then Z1, Z2, Z3, 1, 1, 1, making a determinant. Whereas in the denominator you have Z1 bar, Z2 bar, Z3 bar, Z1, Z2, Z3, 1, 1, 1. With this formula, you will get orthocenter. Now, after finding centroid, orthocenter, and circumcenter, we can make a relation between these three. If you take a line, write the circumcenter here, S, write the centroid here, and write the orthocenter here. Orthocenter you can denote by O or H or whatever it is. We can say that centroid divides the line joining orthocenter and circumcenter in the ratio 2:1. Then next, before going to the next topic, we will learn one formula, that is, if you are given a triangle ABC, A denoted by Z1, B by Z2, and C by Z3, the area of this triangle can be written as 1 by 4 into modulus of determinant of Z1, Z2, Z3, Z1 bar, Z2 bar, Z3 bar, 1, 1, 1. The next is logarithms of a complex number. If you have complex number z, that is x plus iy, we can find log of z. And log of z is nothing but log of modulus of z plus I into augment of Z. And then the next formula or the next point is, if mod of Z plus 1 by Z is equal to A, then we can find maximum and minimum value of mod of Z. How to find? Just take A plus square root of A square plus 4 by 2 and minus A plus square root of A square plus 4 by 2. This I will show you with the help of one example. You will understand better. Suppose in the example, if Z plus 1 by Z equal to 2, and then you have to find, I'm taking the modulus of Z plus 1 by Z equal to 2. We have to find maximum of modulus of Z and minimum of modulus of Z. So as I know A is 2, so I will take 2 plus A square 4 plus 4 by 2. That is 2 plus square root of 8 by 2. Or that is 2 plus 2 root 2 by 2. That is root 2 plus 1. That is the maximum of modulus of Z. Minimum I will get by taking minus 2 plus square root of 4 plus 4 by 2. Or minus 2 plus square root of 8 by 2. Or minus 2 plus 2 root 2 by 2. Or root 2 minus 1. Simple formula. Only thing is calculation is necessary. In this way, we can take some more points like inverse point with respect to line, inverse point with respect to circle and all, but we will learn about them only when we do problems. There are many more synopsis points which I did not tell you, because if you do them with problems, it will be easy for you. In complex numbers, we will study about loci also. In coordinate geometry, you have studied about loci. In complex numbers also, you will study about loci. What is the loci of a circle? What is the loci of interior of the circle? Or what is the loci of ellipse? Like, if you want to find loci, the first one is like a circle. There is a circle. Just one example I'll tell you. The circle center is Z1 and the radius is R. So its loci will be modulus of Z minus Z1 equal to R. Similarly, if you want to learn about ellipse, there is a loci. If you want to learn about hyperbola, there is a loci. For each you will have loci. But here I am not telling you because you will get confused. Apart from that, there are some shortcut methods also. We will learn some shortcut formulas also. Like, first of all, I'll give you some shortcut formulas quickly. If you want to find square root of a plus ib, it will be plus or minus square root of a square plus b square plus a plus I square root of square root of a square plus b square minus a. Of course, for both the denominator will be square root of 2. That you can remember easily. For example, if you want to see how these examples can be done with the help of this formula, suppose you want to find square root of 6 plus 8i. It will be plus or minus. I will write square root of a square 6 square 36, 8 square 64 plus a, that is 6 by 2, plus I into square root of again 6 square 36, 8 square 64 minus a, that is 6 by 2. If you remember the formula, quickly we can do. So you have square root of 100 is 10 plus 6 by 2 plus I square root of 100 is 10 minus 6 by 2. That is plus or minus. You will have 16 by 2 square root of 8 plus I square root of 4 by 2. That is 2. In this way, you got the square root very easily, isn't it? So this is the shortcut formula for finding the square root. Similarly, I told you area of the triangle, how to find the square root formula. Suppose if you want another formula, shortcut formula, suppose I will give you a point represented by Z1, then B, another point represented by Z2, then C, the third point represented by Z3. How can you say these 3 points are collinear, lying on the same line? How can you say? If you take determinant of Z1, Z2, Z3, Z1 bar, Z2 bar, Z3 bar, 1, 1, 1. If you get 0, that means they are collinear. Like that you can use this shortcut formula, isn't it? And similarly, in trigonometry, there are some shortcut formulas which are used here also. Like cos A plus cos B plus cos C equal to 0, which is equal to sin A plus sin B plus sin C also. Then cos 3A plus cos 3B plus cos 3C will be equal to 3 into cos of A plus B plus C. Similarly, sin 3A plus sin 3B plus sin 3C will be equal to 3 into sin of A plus B plus C. In trigonometry, you have learnt all these. In case of triangle ABCs, you have learnt. So cos 2A plus cos 2B plus cos 2C will be 0, which is same as sin 2A plus sin 2B plus sin 2C. So learn all these synopsis points and learn all these shortcut formulas also. We will do lots and lots of questions when we come and meet in the next class.